Recall that in solving linear inequalities, we used an approach that was very much like solving linear equations. Well, now we're going to turn our attention to nonlinear inequalities, and we're going to find out that the method of solution is not at all like solving nonlinear equations. Well, here's what I'm talking about. Here we have an inequality that involves a quadratic part here, a quadratic polynomial. Now, we do start the whole process of solution by factoring our polynomial part, so we get these factors. Now, the zeros of these factors, that is the values of x that will cause each factor to become 0, those are the zeros of the factors, are not solutions, but they're called critical numbers in this process. And I'll tell you why they're critical in just a minute. But the critical numbers then would be the zeros of the factors, and the value of x that causes this factor to be 0 is -2. The value of x causing this factor to be 0 is 3. So those are the critical numbers. We identify those positions on the number line. Here's -2, here's 3. And then we examine the situation of truth or falseness in each of the intervals that are created from these critical values. Now, I say intervals. Now I'm talking about this interval, this interval, this interval. And those intervals were created because of the zeros of our factors that we found. Now, it turns out that if a single value within an interval makes the original inequality true, that every value in the interval will make the original inequality true. And if a value in an interval makes the original inequality false, then every value in the interval will make the inequality false. So all we need to do is check for one value. Let's check out here. Numbers larger than 3, in this interval would be the number 10. Now we can go back up here and test 10 in the original inequality or the factored form. Sometimes it's a little easier to use the factored form. If x is 10, we have 10 plus 2, 12. 10 minus 3 here, 7. 12 times 7, big positive number. Is that less than 0? No. So the values that lie in this interval do not solve the inequality. Let's test in this interval. Well, let's see. Between -2 and 3, one number in this interval is 0. So let's pop 0 in. Put 0 in place of these x's, and we have 2 times -3, that's -6. -6 is less than 0. Yes, that's true. So every value in this interval then will cause the inequality to be true, and we shade within this interval. We'll check the critical points themselves in just a minute. Out here we have something like -10 or some big negative number. Just consider it as a big negative number. Big negative number plus 2, negative. Big negative number minus 3, negative. Negative times negative, positive. Positive greater than 0? No. So the values that lie in this interval don't work. These then are the solutions. Now what about the critical values themselves? If x is -2, -2 was a 0 for that factor. So the critical value makes this 0. Who cares what this is? 0 times anything is 0. 0 less than 0? No. So this number is not a part of the solution region. What about 3? By the same token, 3 doesn't work. It's a 0 of this factor, and therefore it causes this whole side of the inequality to be 0. 0 is less than 0 is not true, so this is not a part of the solution region. The solution region then is the interval from -2 to 3, and in interval notation we would list it this way. Now, let's talk about why these are critical numbers. They're critical numbers because of their separation into intervals. They separate the number line into various intervals. Well, why is that important? And why are we checking here? And what is there a faster way to do this? Well, here's the really important idea here is the positiveness and negativeness of the two factors being multiplied. You see, if we have two positive numbers being multiplied, then they multiply to give a positive result, and positive numbers are not less than 0. And if one of these is negative, just one of them, not both, but if one of them is negative and the other positive, then we have a negative value, and that would give a negative result over here, and that is less than 0, and therefore the statement would be true. Now, the critical points are the places on the number line where the sign for each factor changes. That is, take a look at the situation where x is a number larger than 3. As long as we're in this interval where x is bigger than 3, then a number bigger than 3 minus 3 will cause this factor to be positive. But once we cross over that value 3, if we have a number a little bit smaller than 3, a little bit smaller than 3, minus 3, this becomes negative. So these are critical points along the number line because they are positions where the sign of the factors will change. And in a similar way, this is a position where the sign of this factor will change. Okay, let's take another problem. Here we begin with a situation where we have 3 on the right side. Now, in order to use this factoring technique and the identification of critical numbers, we need to put all the terms on one side and then factor. So we kick the 3 over here by subtracting 3 on both sides. We factor, we identify the critical numbers as the zeros of our 2 factors, and then we pop in those numbers into a number line. And now we're ready to examine the number line. Now, to make that examination, we don't really need to pick a specific number. We can do it like this. We can say, okay, big positive number in this interval. Big positive number plus 3, positive. Big positive number minus 1, positive. Positive times positive, positive. Positive number greater than or equal to 0? Yes, that's true. So this is part of the solution region. Or it is a solution interval at this point. Now, we'll test the critical point in just a moment. In this region, we do need to pick a value in this region. Negative 3 to 1, 0 is in here. Pop 0 in place of the x's, and we have 3 times negative 1. That's a negative value. Negative value greater than or equal to 0? No. So this is not a solution region. Now we kick our thinking over to the next interval. Big negative numbers. Big negative number plus 3, negative. Big negative number minus 1, negative. Negative times negative, positive. Positive greater than or equal to 0. Yes, this is a solution region. The critical numbers themselves. Now at negative 3, we have a 0 here. These are the zeros of the factors. The zeros of the factors, you see, would each cause this product to become 0, and greater than or equal to 0 means truth, and therefore these are parts of the solution region. So now we're talking about the values that lie in this interval along with the values that lie in this interval. Now in interval notation, it's negative infinity to negative 3, including the negative 3. And it's the union of this set with that set, or that we can use the word or. Now the interval here is 1 to infinity, including the 1. And so here then would be our answer. This one has a rather interesting nuance. We begin with a higher degree polynomial over here. We have 0 over here, so we're in good shape to start the factoring process. We snag out a common factor of 4x squared. Pull 4x squared out of this term, we're left with x. 4x squared out of this term leaves us with minus 3. All right, the critical numbers are the zeros of the factors. Now, the 0 for this factor, the value of x that causes the factor to become 0 is 0 itself. So x equals 0 is a critical number. Another critical number is the 0 of this factor, and that would be 3. So 0 and 3. So we have on the number line 0 and 3. Once again, we have 3 intervals. Now the tendency in problems like this is to think that the solution region or the non-solution regions will alternate. That is, if we have a solution region here, then if this is a solution region, that won't be and that will be. They just alternate. And many times that is the case. But it's important to check, as we'll see in this case. All right, in this region, big positive number minus 3, positive. Big positive number squared, positive. Positive times positive, positive. Positive greater than 0, yes. So this is a solution region. Now between 0 and 3, it's best to pick a specific value. 2 lies in here. Let's pick 2. 2 minus 3, negative. 2 squared, 4 times 4, positive. All right, positive times negative, negative. Negative greater than 0, no. So this is not a solution region as we expect. Negative numbers. So negative numbers. Negative number minus 3, that's negative. Negative number squared, positive. Positive number times negative number, negative. Negative greater than 0, no, not a solution region, you see. And so this is not a solution region, nor is that. Now, it might be worthwhile to check out our critical values, this would be rather interesting if we had a non-strict inequality. If we had 0 here, you see, in place of this value, then we have 0 times whatever. This is 0, greater than 0. No, it's not, so it's not a part of our solution region here. But if we had greater than or equal to 0, gee, this value would be part of the solution region, so we would have this point along with that interval, you see, of items. So at any rate, we don't have that here. I'll take it off. I'm taking this off. So we have this. And now, what about this one? Well, this is the 0 of this rascal, and since we have a strict inequality, this is not a part of the solution region either. So our solution region is simply the interval from 3 to infinity, not including the 3. We can also solve inequalities involving rational expressions using the technique very similar to the one that we did here. We're going to identify critical numbers, and those critical numbers are places on the number line where signs change, but this time it's going to be the signs of factors in the numerator and denominator that change, and therefore the quotient may change sign at those points as well. At any rate, we're identifying critical numbers as the zeros of the factors in the numerator and factors in the denominator. Hence the importance now in problems like this. This is a really simple one, but as they get more complicated, it's important to identify the factors in all of the factors in the numerator and the denominator. Okay, here, critical numbers are the 0 of the numerator is -5, the 0 of the denominator is 3. Now, -5, 3. Now we have our interval set up, and we just investigate in each interval. Big positive numbers, let's see, big positive number +5, positive. Big positive number -3, positive. Positive over positive, positive quotient. Less than 0? No, not a part of the solution region. Between -5 and 3 lies 0. 0 in place of the x's, 5 divided by -3, that's negative. Negative less than 0, yes, that's true. So we have a solution region here. Big negative numbers, big negative with -3, negative. Big negative with +5, negative. Negative over negative, positive. Positive less than 0, no, not a solution region. The critical values themselves, well, let's see. The -5 is the 0 of the numerator, so we would have a 0 numerator means a 0 for the fraction, and 0 is less than 0, no, not a part of the solution region. For the 3, so not exactly a similar idea, because the 0 of the denominator makes this undefined. And even if this were a non-strict inequality, this would not be a part of the solution region. You see, it makes this undefined. The whole thing is undefined. We have to throw this out right away. So our solution region is -5 to 3, like this. Here's an interesting nuance in this kind of problem. Now notice the structure of the previous problem was that we had a single fraction that in a factored form that we have on one side of the equation and a real number on the other side, excuse me, and 0 on the other side. So we have something over here and 0 on the other side. Now here we have a fraction on one side and a number on the other side. We need 0 over here. So we have to go through a little manipulation to create the situation of fraction on one side, 0 on the other side. Subtract 3 on both sides. Now we need a common denominator to bring these two together. The common denominator is x plus 2. So we need to multiply this by x plus 2 over x plus 2. So here's what I'm thinking. I'm going to kick this greater than or equal to 0 out a little bit to just illustrate what I'm doing. Greater than or equal to 0. Okay, I'm taking this 3 and I'm multiplying it times x plus 2 over x plus 2. That's what I'm doing here. And I'm thinking of 3 as 3 over 1. The 3 is multiplied in the numerator, the 1 is multiplied in the denominator. So we have, bring down the minus sign, we have 3 times x plus 2, 3x plus 6, and the denominator x plus 2. All right, now, we have to make sure that because we have a minus sign here, we're subtracting this entire numerator, you see. So minus all of this means minus 3x minus 6. And now collecting like terms, x minus 3x is minus 2x, 12 minus 6 is 6. Common denominator comes down. Now we can see our critical numbers more easily, the zeros you see of our factors. If we factor in this numerator, we snag out a common factor, -2. This becomes -2 times x minus 3. I have that up here. So now we can easily see our critical numbers. The 0 of this factor is 3. The 0 of this factor is -2. And away we go. And by the way, there's no value of x that's going to cause this factor to become 0. See, it doesn't contribute to this list of critical numbers at all. All right, now we subdivide our number line accordingly, and we investigate in the intervals. In this interval, big positive number minus 3, positive times negative, negative. Big positive number plus 2, positive. Negative over positive, negative, negative greater than or equal to 0, no. All right, so not a solution region. In between -2 and 3 is 0. If these are zeros, then we have -2 times -3, positive over positive, positive, positive greater than or equal to 0, yes. So we have a solution region in this interval. Big negative numbers. Big negative number plus 2, negative. Big negative number minus 3, negative. Negatives all around. Negative, negative, negative. Negative times negative, though, is positive. Positive divided by negative, negative. Negative greater than or equal to 0, no. So this is not part of the solution region. Our solution region is here. Let's check the critical numbers themselves. The -2 is, let's see, if x is -2, the denominator is 0, the fraction is undefined, can't possibly be part of the solution region. Now let's check the other one. If x is 3, it causes the numerator to be 0, and 0 over a non-zero value, you see 0 here. 0 is greater than or equal to 0? Yes, that's true. And so the 3 is part of the solution region, and our solution then is the interval from -2 to 3, not including the -2, but including the 3.